Okay, let's continue on to our final lesson, Lesson 6. For the Lab 3, the OSI Model TCP Utilities. In this lesson, we'll be observing the ARP process, or the ARP process. Address Resolution Protocol, also known as ARP or ARP, belongs to the TCP suite and is used to determine the OSI Layer 2 MAC address associated with the OSI Layer 3 IP address. This is a necessary process so that Layer 3 packets can be correctly addressed when they are encapsulated as Layer 2 frames. The process takes 2 steps to complete. The first is a request that I broadcast to all nodes on the network asking the owner of a particular IP address to respond with its MAC address. The second is a unicast reply with the required information. Wireshark is a protocol analyzer that can be used to observe this process on the network by capturing the packets and displaying them in a user-friendly format. ARP resides at Layer 3 of the OSI model. Lesson 6.1, Observing the ARP process using Wireshark. On the Backtrack 5 internal virtual machine, open a second terminal window by clicking the icon to the right of the system menu. Start the Wireshark program by typing Wireshark into the terminal window and then press Enter. We're going to type in WIRESHARK and then hit Enter. If a warning appears stating the running Wireshark as the root user can be dangerous, click OK to discard the window. On the Wireshark homepage, choose the ETH0 interface by clicking on it under the Start heading. This is the Start heading, and this is ETH0. Next, click the icon to start a new capture. The icon they are referring to is on top of the menu and third from the left. Once the capture is started, network traffic needs to be generated. Click on the second terminal window at the bottom of the screen. Type the command ping www.isp.com /c 5 and then press enter. So let's open the second window up at the bottom. It was the window we had open before we opened Wireshark. And we're going to type in ping www.isp.com /c 5 and then we'll hit enter. This will issue 5 pings will be issued to the host www.isp.com and will generate the traffic needed for the capture. Click back on the Wireshark capture window and click the button to stop the capture. The stop button is the one with the stop sign up on the top of the menu bar where it says stop the running live capture in the caption. The filter dialog box can be used to display only the protocols needed from the capture. In the filter dialog box, type ARP and press enter. The filter box is underneath those icons, and in the empty field, we're going to type ARP, A-R-P, and hit enter. Only packets captured that use the ARP protocol will be displayed in the capture window. Note that your capture may vary from these figures in the documentation. In step 7, this example shows 4 complete ARP requests: packets 1 and 2, packets 4 and 5, packets 8 and 9, and packets 11 and 12. These can be determined easily by looking at the info column. The first part of the ARP request, packets 1, 4, 8, and 11, in this example, is a broadcast asking whoever has a particular IP address to respond to them with their MAC address. The second part of the ARP request, packets 2, 5, 9, and 12, is the response to this query with their MAC address. Locate one of the ARP requests in the capture and click on it. In the lower capture window, the detail pane, click the plus next to the address resolution protocol request to expand the details of this section. Let's make this window just a little bigger so you can observe it better. Notice the various fields included in the ARP request. The opcode field is set to 1, indicating that this ARP request, also the target MAC address field, is currently all zeros, since as this is the information being requested. Now locate one of the ARP replies in the capture and click on it. The opcode field is now set to 2, indicating that this is an ARP reply. Also, the target MAC address field now contains the MAC address in the destination node. Close the Wireshark program and all open terminal windows by clicking the X in the top left corner of each window. You do not need to save the capture. In conclusion, Address Resolution Protocol, ARP, belongs to the TCP suite and is used to determine the OSI Layer 2 MAC address associated with the OSI Layer 3 IP address. This is a necessary process so that Layer 3 packets can be correctly addressed when they are encapsulated as Layer 2 frames. The process takes 2 steps to complete. The first is a request that is broadcast to all nodes on the network asking the owner of a particular IP address to respond with its MAC address. The second is a unicast reply with the required information. Wireshark is a protocol analyzer that can be used to observe this process on the network by capturing the packets and displaying them in a user-friendly format. ARP resides at Layer 3 of the OSI model. Seems the reservation of the Net+Lab has ended, but that is okay as we are closing out the rest of the lesson. Now let's go over some review questions. Number 1, the ARP protocol is used to determine blank address of a node when the blank address is known. These addresses are called MAC address and IP address. So let me go ahead and reread that statement again so that it makes more sense. The ARP protocol is used to determine the MAC address of a node when the IP address is known. Question 2. The first half of the ARP process is known as the blank phase. That phase is the broadcast phase. Question 3. The second half of the ARP process is known as the blank phase. That phase is known as the response. So the first half of the ARP process is known as the broadcast, and the second half of the ARP process is known as the response. That concludes our lesson.